Hey, we are in lesson 10 of Unit 4. So we're talking about domain and range. Just so you know, get to the page, what our goal is today is to, when we are given a description of a function that represents, a situation, I'll write that in, that represents a situation, we need to determine a reasonable domain and range. Okay, so given a description of a function that represents a real situation, we need to determine a reasonable domain. And remember, domain is our input, our x values, our horizontal axis. Horizontal axis. And then range is our output, our y values, our vertical axis. Okay, those are the two things. All right, so let's get into it. Okay, so earlier you saw a situation where the total number of times a dog has barked was the function of time in seconds after its owner tied its leash to a post and left. Less than 3 minutes after he left, the owner returned, untied the leash, and walked away with the dog. Right? So could each value be an input of the function? Be prepared to explain your reasoning. Okay, if we look at possible inputs, all right, total number of times a dog barked was a function of the time in seconds. So barking was a function of time. So time is in seconds. 3 minutes, we have 3 minutes, 60 seconds per minute, that's 180 seconds. So really, these two can be inputs for this function because 15 seconds is within my domain and 84.5 seconds is within my domain being 180 seconds total. Yep. And then each value being output. Output is our range, and the range is the number of times the dog barks. It's our output. So we could bark 15 times and we could bark 300 times. Oh my word, that's a lot of barking. But we really can't bark a half a time. Okay, that one's not possible because I can't bark. It's like, yip, yip, yeah. Can't bark a half a time. Okay, it's hard to bark for a fraction. All right, we are going to do this card sort in class. Your teacher will give you a set of cards that each contain a number. Decide whether each number is a possible input for the functions described here. Sort the cards into two groups, possible inputs and possible impossible inputs. So possible inputs and impossible inputs. Record your sorting decisions. All right, these are the descriptions. The area of a square, possible inputs, impossible inputs. Tennis camp charges $40 per student for a full day camp. The camp runs only if at least 5 students give or sign up, and it's limited to the enrollment of 16 campers a day. So our input is between 5 and 16. Our output's going to be a function. Multiply that out. So there we go. Possible inputs, impossible inputs. The relationship between temperature in Celsius and temperature in Kelvin is this straight up addition equation. Possible inputs, impossible inputs. All right. So we're going to do that in class. Now, let's talk about 3. What about the outputs? All right, so earlier we learned the domain of a function refers to the set of all possible inputs. In this activity, we are introduced to the range of a function and examine it in terms of a situation. We're going to consider how the domain and range are related. All right, so now we're going to talk a little bit about the output. In an earlier activity, you saw a function representing the area of a square, function A, and another representing the revenue of a tennis camp. That was in task 2. Refer to the descriptions of those functions to answer these questions. All right, so number 1 here. Here is a graph that represents function A, which is the area of a square, where S is the side length of the square in centimeters. Name 3 possible input-output pairs of this function. All right, this shouldn't be too bad. We're going to look at possible input. Okay, if I say my side length, for example, is 2, that means my output would be 2 squared, which is 4. So I can say A of 2 equals 4. That's an input-output pair. 2, 4. Okay, I can also say, let's say 3 over to 9. So I can say A of 3 equals 9. So my input-output pair is 3, 9. And then I could say A of, I don't know, let's do 6. A of 6 equals, oops, there we go, 36. So my input-output pair is 6, 36. Okay, what I've done here is given you 3 different ways to write it. You can write them like this, or like this. Okay, those are two different ways to write your input-output pairs. All right, and then part B says, earlier we described the set of all possible input values of A as any number greater than or equal to 0. How would you describe the set of all possible output values of A? So if the input values of A, we can say S can be greater than or equal to anything bigger than or equal to 0. That means that our output is also going to be anything bigger than or equal to 0. All right? Okay, this would be our domain. And if we look at our x-axis, these are all of the possible inputs. And I can keep going forever. All of the possible inputs into that function. My domain can be S is greater than or equal to 0. Therefore, up here we have our vertical axis, which is our range. That's our output. Well, if our input can be anything bigger than or equal to 0, our output is also going to be anything bigger than or equal to 0. So that is going to be our range. All right, looking at number 2. Function R is defined by R of n equals 40n, where n is the number of campers. Okay, it's the tennis camp, so n is the number of campers. And for each camper, they make $40 extra for the day camp. All right, so is 20 a possible output value in this situation? Well, if we have R of n equals 40n, the only way I'm going to get 20 for my output is if n equals 1/2. All right, can n equal 1/2? N is a person. Can I have half a person? No, I can't have half a person. So is 20 a possible output value in the situation? No, it isn't. What about 100? Well, to get 100, I can go backwards here. N equals 5/2, which is 2.5. The only way to get an output of 100 is have my input be 2.5. Can my input be 2.5? No, because my input is a camper. I cannot have a half a person. Okay, not possible, and still play tennis. I think it was a tennis camp, wasn't it? All right, so here are two graphs that relate number of students and camp revenue in dollars. Which graph could represent function R? Explain why the other could not represent the function. Well, if I look at this, it looks like I can get an output of 100 with this number of students. I can't get that. Let's see. An output of 300. 5, 6. If I have 7.5 students or campers, all right? This is a linear graph. Goodness, linear graph. And this one is what we call discrete. This one gives me actual values. So if we have 5 students, $200, 10 students, $400, 15 students, $600. And if you remember, we can go back and look, we had some very important 5 to 16 campers a day, which is why our input goes from 5 to 16 campers a day. So our domain is going to be between 5 and 16. The number of campers is bigger than or equal to 5 and less than or equal to 16. And our range is going to be $650, $640. I think that's right. 16 times 40. Yeah, that's right. Goodness. But for both the domain and the range, our domain is going to be integers only. We can only have integers as our domain because we can't have a half a person. That's not possible. And that actually drives our range to be only integers too. We could say for the range as multiples of 40, which is very important. Let's make sure I get everything. Yep, cool. All right, what could be the trouble? It's optional, but very important. Consider this function. To find out the sets of possible input and output values of the function, Claire created a table and evaluated f at some values of x. Along the way, she ran into some trouble. Find f of x for each x value Claire listed. So let's do it. 6 divided by x minus 2. So I'm going to plug in -10 for x, and I get -1/2, -3, -0.5, -4, 6 divided by 2 minus 2. Am I allowed to divide by 0? We can say DNE, which means does not exist. It's undefined. Is another thing we could say. Or we could say the world blows up because we tried to divide by 0. Okay, so that right there is a problem. And then if I plug in 8, I get 1 for my answer. All right. Now, if we used graphing technology, let's see if I can do that. Why isn't it sharing this screen? I lost my face.